Hello friends, this is Durga from IT Varsity. At this time we are talking about joining disparate datasets together using Spark as part of CCA Spark and Hadoop developer using Scala as programming language. We have already seen how we can use the complete Scala syntax to join the datasets, but at times it can sound complicated because to apply logic such as getting the revenue and number of orders from by joining orders and order items table, you have to write many lines of code, uh, starting from reading the data. So there are two lines of code to read the data and then two lines of code to process and create RDDs so that they can be joined, and then we can join, and then we have to again apply map functions to process to get the results the way we want. It's very simple compared to Java, but compared to SQL, if you're already familiar with SQL, this is a little bit complicated. So, but yeah, you can actually use Spark shell in Scala context, and you can also run queries on tables in Hadoop if the tables are in Hive. And already when we actually scoop the data, we not only scooped into the HDFS under user Cloudera scoop import, we have also created the tables in Hive. So for that you can actually go into the VM, run Hive command to get into the Hive command line interface, and then show tables and hit enter. You can see tables such as orders, order items, etc. So you can also run select star from orders, limit 10. So if you follow my videos in a series, you will definitely have these tables. Otherwise, go back and run the scoop import the way I have shown as part of the videos, and then you will have these tables, orders and also order items. You can run SQL in Spark shell using Hive context. By default, when we launch the Spark shell, whether it is local mode or yarn, it will launch the Hive context also. So you can directly connect to Hive tables from Spark shell, and then you can embed that as part of the Scala script, and you can run a query as part of the Scala script or command. Okay, so for that you don't need to read the data and all those things. You just make sure that you are using Hive context. Let me see. I think it have not started Hive context because we are using 1.2.1. Latest versions will actually start the Hive context, but you can easily import the Hive context by running this command. So Hive context is in the package org apache spark sql hive. Copy, paste and hit enter. Now you can use the Hive context. For that, first you need to create a variable. I am creating the variable SQL context by calling the constructor on Hive context and passing the Spark context as the parameter. So this SC will be available when you actually run the Spark shell command successfully. You can see it here. Okay, and hit enter. Now you can use SQL context to run our queries. So first we will set a parameter called Spark SQL shuffle partitions. Otherwise it will use too many processes to execute the queries. By default it uses 200. To control that, we need to run this command, Spark SQL shuffle partition. So it will use fewer number of tasks to execute the query. So for development purpose you can play with this, but for production purpose you need to understand the parameter in detail and modify that value to more appropriate value depending upon the characteristics of your dataset. Anyway, we will not be covering too much about performance tuning here. Just run this for our dataset. It works well. If you use the default, it will run 200 tasks and it will take a very long time if you don't set the Spark SQL shuffle partitions to a lower value. That being said, we will test a simple query. Set context dot SQL, select star from orders limit 10. Okay, and then we want to collect the result, and then for each println and hit enter. Now it will run the query and it will get the results for you as a query. Okay, you can also say select order date, order ID from orders, and it will only fetch those two things from the table. Okay, so now you can assign it to a RDD and you can do whatever you want, but you can write more complex queries also. The simple joins work in the same way, the syntax is same way as traditional RDB businesses. So you can write a simple join query for our result set, for our problem statement. Let's revisit our problem statement by going to my code in my GitHub account. The problem statement is to get the revenue and the number of orders from order items on daily basis. So I need order date from orders table and distinct number of orders for each day from order items table, and also the total revenue for each day from order items table. So I need to join these two. So it's what you can do is SQL context dot SQL, in double quotes select O dot, so O will be alias for my orders table, order date, comma OI will be alias for my order items table, and I want order item subtotal, and I want to do the sum. And then count of distinct order item, order ID from order items table, and here I have to say OI dot. Okay, and from orders join order items, orders O, order items OI on O dot order ID equal to OI dot order item order ID, and I have to group by order date. So I have to use group by O dot order date, and I want to get it in proper order. So I can say order by O dot order date. So I want to sort it by order date. Hence now the query is complete. It's a simple join query with group by clause and order by to get the results in the way we want. So if you are familiar with SQL, it is very easily understandable. And close the bracket, collect for each println and hit enter. Now it is running the query. If you see, it's just one line query with your familiar SQL if you are from SQL background, versus the more complex query like this. But it seems so it is giving too many decimals, so you can actually apply round function also on top of order item subtotal, so that it will reduce the number of decimals. So if you are already familiar with SQL, you can use most of the simple SQLs, but if it is more complicated, there are significant differences between traditional SQL and the Hive or Spark SQL. So you need to be familiar with those subtle differences. If you are familiar with Hive and if you can run Hive queries without any issues, you can execute most of the Hive queries in Spark context and get the results. Spark uses the same parse engine, but the compilation engine and all are a little bit different. So most of the Hive queries will run on Spark, and they will be parsed in the same way, but they will be compiled and run in a significantly different manner, which you don't need to worry much, as long as you can put your you can solve your problem statement using simple queries. You can write simple queries and you can execute them in Hive context, and you can see the results here. For each date I got the order revenue and the number of orders from order items, number of distinct orders from order items for each day. So that being said, we successfully ran our problem statement using Hive context, and Spark also supports something called SQL context. So Hive context, you can run any Hive query in Hive context, but it requires tables to be created in Hive. But some cases the tables might not be there in Hive, but a structure can be defined on top of Hive. In those scenarios, you can use the SQL context of Spark. So for that you have to say import org.apache.spark.sql context. I think it's spark.sql context. Yeah, okay. Yeah. Q and L are capital. When you are using SQL context, you need to import this one also, org.apache.spark.sql.row. So remember the difference between Hive context and SQL context. Hive context can be used when there are Hive tables, and if you want to run queries against those Hive tables. But in some cases you might have structured data on which structure can be defined easily, but there are no Hive tables. In that case you can use SQL context to create temporary tables on the fly and use those things for your queries if you can write your requirement in a query. Okay, so now we are using the we have imported the SQL context and row. We have to create a variable by invoking the SQL context constructor with the Spark context parameter, and here I am setting the shuffle partitions to 10. After that we need to read the data. If you don't have the structure, if you don't have the Hive table, you have to read the data and you have to create the structure on top of it. So here I am reading the data, and then I am splitting the data by using the delimiter. Okay, so the RDD is nothing but a array for each record. The array is created by splitting using the delimiter, which is comma in this case. So I can copy it and paste it, and now I can say orders map dot take of 5 dot for each println and hit enter. You can see it is actually showing you a array of string. Okay, now we can create a class for orders. Scala have a concept of case classes. So in this case I will not get into the too many details about what case class is and all. You can just create a class. So our orders have 4 columns: order ID, order date, order customer ID, and order status. Order ID is of type int. So this is how you can define variables in Scala. This is variable name and then colon and then the data type. Similarly, this is another variable name in the case class, or attribute name in the case class, and this is the data type, and this is another attribute, and this is the data type, and this is the last attribute, and this is the data type. So I am creating a case class for orders and hit enter, and then I am running the map function on the array list which is generated, and creating a RDD called orders. And now using this orders RDD, I can actually import create schema RDD and then register the temp table by passing this RDD name. Okay, so this and this should be same. Sorry, this and this should be same, and this will be the table name. When we write the queries, whatever you have specified in the double quotes will be the table name, and this is the variable which is assigned with the case classes for each of the record. Okay, now you can run these two statements. make sure that you understand this is the table name which will be using the query. So you can copy paste these two. And now we have created a table on the orders table. You can validate by saying select SQL context dot SQL select star from orders limit 10 dot for each println and hit enter. You can see that it is giving 10 records from the result set because the query is limit 10 query. Similarly, we need to read the order items table from scoop import order items, and then we have to create an array list for each of the record the same way we have done for the orders table. And then we have to create the case class. Order items have 6 variables. The first one is order item ID, second one is order item order ID of type int, third one is order item product ID of type int, fourth one is order item quantity of type int, fifth one is order item subtotal of type float, and last one is order item product price of type float. So we need to create a case class if we have to use SQL context to run our queries. And hit enter. Once the case class is created, we need to process the array list and build the class order items for each of the record in our data set. Okay, so we can run it here. So you can skip this here because I have the complete logic here. I'm not using order items map because I am reading the data and then applying the map function to create the array list, and then applying the map function to create the order items case class object for each and every record in our order items data set. And here you can see that this will be the table name order underscore items, and we are creating the table on top of the RDD order items, which is nothing but this one. Now you can actually run this, and then you can run the same query which we have written earlier to get the sum of order item subtotal, to get the count of distinct order items, etc. And then group by and then order by, and then copy and paste it here. Okay, it has created the physical plan for our query, and now we can say join ag data dot collect for each println. Join ag data is the RDD which is generated based on the join query, and then I'm collecting all the records, and then for each I'm printing the revenue and the number of orders for each day. Now you can see the same results using a different approach. So far we have seen how to join the dataset using complete Scala programming semantics, and then we have seen how we can actually run the Hive query in Hive context if the tables are already present on top of our data, and if the tables are not present and if you can easily create the structure, you can use SQL context, read the data, map it to a case class to generate a case class object for each of the record, and then register the resulted RDD after applying the case class as a temp table with some table name, and then you can use those table names to run typical SQL queries on top of those datasets. We have seen all three possible ways to achieve that. That being said, I hope you enjoy the content on the channel. If you like this video, please click on the like button. If you want to provide the feedback, please use the comment section of the video. If you want to ask any technical questions, go to Stack Overflow and tag the questions with appropriate tags. And if you want to join or if you want to discuss more about certifications in Hadoop world, please join my LinkedIn group called ITversity minus Hadoop certifications. And if you have not subscribed to my channel yet, please do so. You will get to see a lot more content like this over time. That being said, thank you. Bye.